3D figures and cross sections. In this first slide, I'm showing examples of some common 3D figures, and we're going to go through three different terms: faces, vertices, and edges. A face is a surface of one of the sides, the 3D figure. A vertex is where two lines come together and join, and an edge is a line. We're going to look at the tetrahedron first, and I'm going to identify the faces. So I'm going to shade them. So the first one I'm going to shade is this back side of this triangle. That's one surface. The next surface is the bottom triangle. The third surface is this triangle that's kind of facing the right-hand side. And the last surface is the triangle that we're kind of looking through. So imagine that it's transparent and we're able to look through it to see the other three faces. So this has a total of 4 faces. Now I'm going to erase this just so it's not overly cluttered when we talk about vertices. So vertices are where two lines come together, but really in this case our lines are our edges. So we have one vertex here, one at the top, one on the bottom right, and then one on that kind of top right. So we have a total of 4 vertices. And then edges are the sides, the lines that we're seeing. So I'm going to overlap every single line to make sure I don't miss one. So we have 1, 2, 3, 4, 5, and then the back side that we can only see because we can see through that front face. So it looks like we have 6 edges. Now let's try the cube. So we're going to do the surface first. So I'm going to do that back square, and one of the sides, the right hand side, I'm doing that yellow so it might be a little bit hard to see. Then we have the top that I'm doing in green, that bottom that I'm doing in that light purple, and then the face that we're looking through. Imagine it's transparent, and that's why we can see the other faces. So we have a total of 6 faces. The vertices are where the lines come together. 1, 2, 3, 4, 5, 6, 7, and 8. And then our edges, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why don't you guys try and do the octahedron? This has 8 faces, 6 vertices, and 12 edges. We're going to go through example 1, and then what I'm going to do is going to show you a relationship that's made between vertices, edges, and faces. So we'll start on the left-hand side. So for the faces, we have this back triangle, the left-hand side, the right-hand side, the bottom, and then what we're looking through. So we have a total of 5. For vertices, 1, 2, 3, 4, 5, 6. And for edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. For the rectangular prism, another way you can think of this instead of doing the shading, you can think of the top of the rectangular prism is square, and off of each edge of the square is going to be a face. So you have four faces that kind of wrap around the outside of the rectangular prism, and then you have a top and a bottom. So in total, you're going to have 6 faces. Now, of course, you can do the shading. I just want to give you another way to think about it. Then for vertices, we have the 4 corners on the top and the bottom. And then for the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For the pentagonal prism, a pentagon has 5 sides, so 1, 2, 3, 4, 5. If you think of the top as a pentagon and the bottom as a pentagon, that's going to be 2 faces. And then each edge of the pentagon is going to create another face. So 1, 2, 3, 4, 5. So in total, we have 7 faces. Then we go to the vertices, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The last one, the hexagonal prism. So that means that this polygon facing us has 6 sides. 1, 2, 3, 4, 5, 6. Then we have the face at the back. So that's the front and the back is 2. And then each side of the polygon is creating a surface or a face. So 1, 2, 3, 4, 5, 6. So in total, we have 8. For the vertices, I'm going to do the back side first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 12. And then edges, you want to think of it this way as well. For edges, we have 6 on the front face, we have 6 on the back face, and then we also have 6 connecting from the front to the back. So we have a total of 18. There's a relationship that I want to point out between the faces, vertices, and edges. So for the triangle, the faces is 5, the vertices 6, the edges is 9, and then we add 2. Is the left side equal to the right side? 11 is equal to 11. That is true. What about the rectangular prism? We have the faces, which is 6. We add the vertices, which is 8, equal to 12 plus 2. So 6 plus 8 is 14, which is equal to 14. So that's true. So this is a relationship that you need to know as well. Now I want you to try and find the faces, vertices, and edges. So I'm going to pause here, and then I will display the answers so you can check your answers. Example 2. To make a polyhedron-shaped game piece using a 3D printer, Juanita enters the number of faces, edges, and vertices into a program. If she wants a game piece with 20 faces and 30 edges, how many vertices does the piece have? So we'll start with our formula. Faces plus vertices is equal to edges plus 2. We'll plug in what we know, 20 faces and 30 edges. The 2 will just carry down on the right hand side, and then we'll rearrange and solve for v. So I'll subtract 20 from both sides. So we have 32 minus 20 will give us 12 vertices. The formula that we're actually applying is called Euler's formula. The sum of the number of faces and vertices of a polyhedron is 2 more than the number of its edges. Now I want you guys to try this one on your own, so go ahead and pause, and then I'll show the answers and you can check your answers. In the next question, we're going to imagine that we have these three-dimensional figures that we've been talking about, and then we have a second three-dimensional figure that is a plane, so it's a flat surface. And imagine that that flat surface is like a knife that's going to slice through your three-dimensional figure. So in this case, the question is saying, if we take that flat surface and we slice through, what is the cross section? So imagine that we took the top off here and then we looked down. What is the shape that we are going to see? So the shape that we're going to see is a pentagon because it has 5 sides. So you really have to use your imagination with these types of questions. So what is the 3D figure? What are the edges that it has? And if we slice through it and separate into 2 different parts, and then you take a look at how many edges you're actually looking at after that slice, what would the shape be? The next question is saying that we're going to take a 2-dimensional shape and we're going to spin it on an axis. And the question is what is the 3-dimensional shape that is created once we spin? So the first one is a rectangle. Now imagine that we created an axis. It doesn't really matter where. We can do a horizontal one and a vertical one. And then we spun this rectangle. So this point on the axis, this side of the rectangle on the axis, cannot move. And then we're going to rotate. Well, as it spins, it's going to actually create a cylinder. And I've inserted a 3D picture to hopefully give you a better visual. So this is the side here that is locked on our axis. And then the other side is creating the cylinder, where the radius is the width of the rectangle. Here are a couple more figures to get some better visuals. You'll see the 2-dimensional shape rotating around.